So now that we've talked about normal theory method, let's talk about bootstrap distributional method. And I really want to stress that bootstrap distributional method is a broad name for a series of different ways to look at this. All of them are similar or bound together by the fact that they're using, like I said, an integral iterative process to determine whether or not the relationships that you're looking for in the model of the mediation is occurring not due to chance, but due to a systematic mediational process. So this method stemmed from criticisms of the normal theory method. The first one, of course, is that step one is not necessary to determine mediation. So step one, though it occurs most of the time, mainly because there's almost always the appearance of a direct relationship if there is a mediation, it is potential to find a relationship where it isn't. Step 4 assesses complete mediation but does not address partial mediation, which means that if you have full mediation, there's a little bit of a question of why you would need to continue to step 5 with the Sobel's test, but also the Sobel's test, though, is required for partial mediation. In other words, step 4 and 5 are kind of doing two separate things at the same time. Also, estimates are not robust when the data is non-normal. So because every one of these steps is a regression, and it's a series of regressions, every one of those regressions needs to have normally distributed data, and each one of those regressions needs to be checked to make sure that you have the assumptions met to run the regression. Which means that if you have some variation in your data sets, if your data is not normally distributed, it is hard to run a normal theory method model. And estimates are easily affected by low power, i.e. when sample size is less than approximately 80. And again, partly the reason for this is that we are running a series of regressions. And to be reliably trusting each one of those regressions, because it's kind of a house of cards. You have C, A, and B, and C prime. You have to trust every single one of those regression coefficients to be able to trust your mediational model. So again, bootstrap distributional method is not necessarily a better technique when you're looking for mediation and you have normal distributed data and you've got a fairly large sample size. In other words, if we actually ran the easier to do normal theory model and then ran a bootstrap distribution method on the same data set with normally distributed variables with a large N, we probably wouldn't find really any difference 99+% of the time. However, not all data is pretty looking. And if you've got some data problems where you have some slight basically your assumptions have been violated by some of your data normalcy, or you just have low power, you can use the bootstrap distributional method. The reason that I don't go into as much on the specifics is that I have personally found there's a lot of macros out there. And again, macros is simply a line of code. It's usually a cut and paste code that you put into the syntax area of SPSS. There's a lot of different people that have come out with slightly different codes, and also there's different statistical packages that are actually made to do these techniques. Therefore, I'm really just looking at this at the theoretical level, and if you decide this is the way you want to go, this is something where you would research a little bit what's the specific technique and macros you're going to use for the statistical program that you're currently using for your analyses. So how does this work? The first thing is we create a bootstrap sample of N from the original data set. And how we do this is we randomly select with replacement the same number of units from the data set that are in the data set. Now, for example, if Jared had collected a sample on 75 men, now once again, we've got 75 participants from this study. Again, below 80, we start to have some problems and questions of whether or not a normal theory method would be able to detect a mediation. So that might be a good reason we're using bootstrap distribution. I would now randomly sample from my data set a new sample, still of an N of 75, using replacement. He would draw some of the same units more than once. So in other words, I'd randomly select from 1 to 75 the number 37. That participant is going to be in my new data set. However, when I choose the next random person, and I'm going to do this 75 times, I'm going to grab someone randomly from that data set of 75. If I grab number 37 again, 37 would now be twice in that particular data set. And in this way, every time we do this, each data set is going to be slightly different from the other one. So each bootstrap sample will be very similar to the original data set, but will not be identical. We then estimate the indirect effect of the relationship on the predictor and the outcome variable and save this estimate. This estimate is similar to step 5, so in many ways we're actually kind of going backwards. We're first asking what is the overall mediational strength. The path estimates are then computed for A and B. In other words, beyond the actual mediational effect, what is the direct effect left over? So if you think of this from a kind of a multiple regression model, instead of giving variance first to the direct effects, we're giving variance first to the actual interaction or mediation, and then seeing what's left. The indirect effect is then the product of A times B, the relationship between the predictive variable and the mediator, and the relationship between the mediator and the outcome, and we're going to save A and B as well. And what I mean by save is that if we were actually doing this by hand, most of this is going to be done by the macros and the computer programs that we're going to use to do it. But we're basically generating different numbers. The first thing we're generating is the overall mediational effect. The second thing we're looking at is the actual strength of the direct effects, A and B, and we're putting both of those aside. Step 3 is we're going to repeat steps 1 and 2 several times. These are the iterations. The number of replications depends on the speed of your statistical package used to conduct the bootstrap sampling and compute the coefficients. J of 1,000 to 10,000 is common. In other words, we're going to run this analysis at least 1,000 times, over and over and over again. Every time we're going to calculate the overall mediational effect, every time we're going to calculate the direct effects. And we're going to do that over and over and over. We're then in step 4 going to create confidence intervals. We're going to determine whether 0 is within the 95% confidence interval for the distribution's indirect effect estimates. If 0 is within that interval, there is not an indirect effect and mediation does not occur. In other words, do we find mediation 95% of the time or more by doing these iterative processes? So again, as long as the mediation effect is found to be beyond the actual chance of a 5% error, the distribution of indirect effects is considered to be significant. So again, we're not getting a p-value, we're simply getting a confidence interval that the mediational effect is significantly likely not to be 0, 0 being no effect. So in the bootstrap distributional method, an effect ratio is often computed to determine the strength of the mediation. And this is simply A and B, the direct effect, divided by the mediation itself. Partial mediation is evident in bootstrap distribution method if the direct effect is not nullified when the mediator is added to the model, again C prime. But the effect ratio is significantly greater than 0. And again, we'll be using confidence intervals to determine this. So we're going to also get information about how much is C prime left once we've actually put the full mediation in the model. So again, summary of regression results. An unmediated model simply means what is the direct effect between types of music and number of items purchased. The mediational model, whether we use a bootstrapping technique using some form of macros and computer statistical modeling program, or simply run through a series of regression analyses using the 5 steps of normal theory, do we find that actually type of music directly impacts time of attention, which directly impacts the number of items purchased, in this case, a full mediational model. So for even more about mediation, I suggest you check out both of these pages, David and Kenny's webpage, which currently I think is actually updated to say you should just use Bootstrap's models if you have the access to them, and also Preacher and Lombardi-Ellie's webpage that has the Sobol's test, and both of those will have some more information about these techniques.